Students, I am Shikha Gautam and today I will discuss with you some topics of Chapter 1 sets of your Class 11th Mathematics book. If you remember, in the previous session we had discussed about various kinds of sets, which were empty sets, finite sets, infinite sets and equal sets. Then we learnt about Venn diagrams and operations on sets. These operations were union, intersection and difference of sets. In today's session, we are going to learn about complement of a set and discuss some practical problems on union and intersection of sets. The complement of any set A is the set of all those elements of the universal set which are not elements of A. The complement of a set is denoted by A dash, which implies not in A. Let us take an example to study this in detail. Let U be a set containing the elements 1, 2, 3, 4 and 5, and let A be its subset containing the elements 1, 2 and 3. Then A complement will be written as U minus A, that is all the elements of the universal set which are not a part of set A. This set will contain the elements 4 and 5 only. With the help of a Venn diagram, it can be represented like this. If U is the universal set and A is the subset, then all the elements of set A are written inside the circle. 1, 2, 3 are written within the set A. But the elements which are not the part of set A but are part of the universal set are written outside the set. That is 4 and 5 are not part of set A, so they are written outside the set. So elements 4 and 5 will be a part of the complement set. Mathematically, we denote it as A dash is the set of elements X such that X belong to the universal set and X does not belong to set A. The Venn diagram can be represented like this. Here, U is the universal set and A is the set A. This shaded part will represent the complement of set A, that is A dash. Let us now discuss the properties of complement of a set. The first property is the complement laws, which says that the union of a set and its complement will give us the universal set. That is, A union A dash will be equal to U. And similarly, the intersection of a set with its complement will give us a null set. That is, A intersection A dash is equal to phi. The second property is the law of double complementation, which states that the complement of a set gives the set itself. That is, A dash dash gives us A. The third property is the law of null set and universal set, which states that the complement of a null set gives us universal set and the complement of a universal set gives us a null set. Mathematically, it can be written as phi dash is U and U dash is phi. Another very important property of complement of sets is the De Morgan's law, which states that the complement of union of two sets is same as the intersection of their complements. That is, A union B dash is same as A dash intersection B dash. Similarly, the complement of intersection of two sets is same as the union of their complements. That is, A intersection B dash is same as A dash union B dash. Let us verify the De Morgan's law with the help of an example. Let U be the universal set containing the elements 1, 2, 3, 4, 5, 6 and A be a subset containing the elements 2 and 3. Let B be another subset containing the elements 3, 4, 5. Then A complement will be denoted by U minus A. That is, all the elements which are a part of the universal set but not the set A. That means this set will contain the elements 1, 4, 5, 6. Similarly, B complement will be given by U minus B. That is, all the elements of the universal set which are not a part of set B. The set will contain the elements 1, 2 and 6. Now the intersection of A complement and B complement will be the set of elements which are common to both the sets. So this set will contain the elements 1 and 6. A union B will be the set of elements of set A and set B taking the common elements only once. Therefore, A union B will contain the elements 2, 3, 4 and 5. The left hand side of the De Morgan's law says that the complement of union of two sets A and B, which is written as A union B dash, is given by U minus A union B. That means all the elements of the universal set which are not the part of the union. So this set will contain the elements 1 and 6. Similarly, the right hand side of the De Morgan's law is A dash intersection B dash, which we have shown earlier that comes out to be the set containing the elements 1 and 6. So now we can see that the left hand side is the set containing elements 1 and 6 and the right hand side also comes out to be a set containing elements 1 and 6. We can verify the other part of the De Morgan's law using the same example. Let me recall the other part. The other part was that the complement of intersection of two sets is same as the union of their individual complements. So students, now we have finished discussing the complement of a set. We are now going to discuss some practical problems on union and intersection of sets. Let A and B be finite but disjoint sets. That is, A intersection B is a null set. Then number of elements in A union B will be given by number of elements in A plus number of elements in B. Mathematically, it can be written as n of A union B is equal to n of A plus n of B. In general, if A and B are finite sets, then number of elements in A union B will be given by number of elements in A plus number of elements in B minus number of elements in A intersection B. Mathematically, it is written as n of A union B is equal to n of A plus n of B minus n of A intersection B. Let us now take a few examples where we can apply these properties. In a class of 35 students, 24 like to play cricket and 16 like to play football. Also, each student likes to play at least one of the two games. How many students like to play both cricket and football? Let us try to convert this data in the form of sets. Let X be the set of students who like to play cricket and Y be the set of students who like to play football. Then X union Y is the set of students who like to play at least one of the two games and X intersection Y is the set of students who like to play both the games. Then according to question, the number of elements in the set X is 24. That is, n of X is 24. And number of elements in the set Y is 16. That is, n of Y is 16. Also, the number of elements in X union Y is 35. That is, n of X union Y is 35. In this problem, we have to find the number of elements in the set X intersection Y. Here, using the formula n of X union Y is equal to n of X plus n of Y minus n of X intersection Y. Placing the given values in this formula, we can easily find the value of number of elements in X intersection Y. So I think you can do this on your own. Let us take another example and apply the property again. In a survey of 400 students in a school, 100 were listed as taking apple juice, 150 as taking orange juice, and 75 were listed as taking both apple as well as orange juice. Find how many students were taking neither apple nor orange juice. Let us convert this data into sets. Let U be the set of students surveyed, A be the set of students taking apple juice, and B be the set of students taking orange juice. According to question, number of elements in the universal set is 400, number of elements in set A is 100, number of elements in set B is 150, and number of elements in the intersection of A and B is 75. In this question, we have to find the number of elements in the intersection of A complement and B complement, which will give us the set of students who do not like apple juice and who do not like orange juice. This will be given by number of elements in A union B complement, which, as we all recall, is the De Morgan's law. This can be written as number of elements in the universal set minus the number of elements in A union B, because complement means all the elements in the universal set which are not part of A union B. Applying the identity here, we can say that number of elements in U minus number of elements in A plus number of elements in B minus number of elements in A intersection B will give us the required answer. Students, you can try to simplify this problem yourself. The answer will come out to be 225. Let us take one last example. In a survey of 60 people, it was found that 25 people read newspaper H, 26 read newspaper T, 26 read newspaper I, 9 read both H and I, 11 read both H and T, 8 read both T and I, and 3 read all the 3 newspapers. Let's convert this information in the form of Venn diagram and try to answer some questions. Let us assume that H is the set of people who read newspaper H, T is the set of people who read newspaper T, and I represent the set of people who read newspaper I. Then the Venn diagram will be represented like this. H, T and I will be represented inside the universal set. Let's denote all the segments of this Venn diagram by small alphabets. Let this part be represented by A, this be represented by B, C, D, E, F and G. Then according to the question, number of elements in set H is 25, number of elements in set T is 26, number of elements in set I is 26, number of elements in set H intersection I is 9, number of elements in set H intersection T is 11, and number of elements in set T intersection I is 8. The number of elements in the intersection of all the 3 sets, that is H intersection T intersection I, is 3. With the help of this information, let us find out the values of all these small alphabets. A is given to be 3. If we see in the Venn diagram, B plus A is given to be 11, which implies that B is 8. Similarly, D plus A is 9, which gives that D is 6. Also, according to the question, C plus A is 8, which will give us that C is 5. Also, E plus B plus A plus D is 25, which gives us that E is 8. F plus B plus A plus C is 26, which gives F as 10. And lastly, G plus D plus A plus C is 26, which gives G as 12. Now that we have found all the values of the small alphabets, we can answer as many questions as asked. For example, if we have to find the number of people who read at least one newspaper, that means we have to find the number of people who read one or more newspapers. This will be given by A plus B plus C plus D plus E plus F plus G. So if we add all this, you will get the answer 52. Students, if you simplify, this comes out to be 52. Let us ask another small question. Find the number of people who read exactly one newspaper. This will be E plus F plus G. If you simplify this, the answer comes out to be 32. Students, let us now recapitulate whatever we have done in this session. We have discussed about complement of a set and its properties, and some practical problems on union and intersection of sets. With this, we have completed Chapter 1, Sets and its Applications. I hope you all have had an enriching experience in learning this chapter. Thank you.